Hello everyone, we'll be starting with the session now. Hello everyone, good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 6A. Myself Anshika Jain and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GIAS Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Intelligent Systems ICTIS 2025 New York, USA. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in New York, USA, and the virtual event is being held through yesterday and today, that is 23rd and 24th May 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 8 presentations, and each presenter will be given 12 minutes for the presentations and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or any updates, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for this session, Dr. Tran Thi Min Koha is a lecturer at the University of Botswana, specializing in data mining, information science, databases, data mining, and data structures. Her research interest includes IoT protocols, AOIT, computer networks, particularly underwater networks, and wireless sensor networks. MAM is dedicated to advancing technology in applications in connected and intelligent network systems. She is a lecturer at Industrial University of Ho Chi Minh City, Vietnam. Welcome to the session, ma'am. Would you like to share a quick opening remark with us? We are unable to hear you, ma'am. Can you please unmute yourself?
Oh, sorry.
It's okay.
Good morning, good afternoon, and good evening, everyone. And I'm very honored to be one of the 2 sessions chair in this conference. And I hope that we have the fully researching time with each other. Thank you.
Thank you, ma'am. Welcome to the session. I would also like to introduce you to Dr. James Stephen Meka. Sir is a full-time chair professor, Dr. B.R. Ambedkar Chair at Andhra University, and is also serving as a dean, Transdisciplinary Research Hub of Andhra University. Sir holds more than 21 years of experience in teaching, research, and administration. He has published more than 50 quality research papers in international journals of high repute and has authored 10 books. He is an expert in amalgamating technology with social needs. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Yeah, thank you for the kind words. And I'm so happy that I'm part of this wonderful conference, International Conference on Information and Communication Technology for Intelligent Systems. I'm so happy to learn from the various presentations and try to collaborate and consolidate whatever the knowledge that is being presented. Thank you, and looking forward to listen to more presentations and more discussions in the due course. Thank you.
Thank you so much, sir. So we'll be starting with the papers now. First, we have Mathi to present the paper titled Comparative Performance Analysis of CUDA and OpenMP Offloading for BLAS Operations on GPU. Are you there?
Hi, good morning. Yes, I'm here.
Yeah, you may please begin with your presentation.
Yeah, sure. Let me share my screen.
Yeah. Yeah, we can see your screen.
Okay, thank you so much. Good morning, everyone. So my name is Mathi Krishnasamy. I'm presenting my work from Luxembourg. So the work is about comparative performance analysis of the CUDA versus OpenMP offloading for these BLAS operations, basic linear algebra subroutines on the GPUs. So this is my outline, introduction. I'll just briefly go through this work, and then programming and OpenMP offloading. So what kind of opportunities we have in OpenMP offloading, and also I will continue presenting what kind of opportunities or methodologies that we have used in this programmability options. And then I will continue also again with the methodologies that we have tried within this work. And finally, I will discuss with the results and discussion, and then I'm concluding with this conclusion on future work. So blast routines are like very, very essential in fields like scientific computing. So when we say scientific computing, it's like wherever we do this mathematical modeling with arithmetic computations, it comprises of this scientific computing. For example, which includes like a plasma physics, or astrophysics, or machine learning, or computational fluid dynamics, or solid mechanics, and so on. GPUs have been like really very demanding or very famous within the scientific community, scientific computing community. There have been like lots of programming options available to enhance this scientific computing on the GPUs. So one of them is OpenMP offloading. So OpenMP is a directive-based programming language, which means like they provide some kind of like APIs. By using these APIs, we can parallelize computational tasks, but it has been only available for some years back, only for the CPUs, but recently they also support like a GPUs as well. Of course, most of the scientific codes which are written in C and C++. So in order to like port the scientific codes using this OpenMP offloading could be like good options, but we don't know like how much this OpenMP offloading could be like very efficient compared to like CUDA or other low-level programming languages and so on. So this is what we have explored in this in our work, and then as you can see, we have tried this some of the basic fundamental BLAS operations, such as like a vector dot product, vector addition, matrix vector multiplication, and then matrix multiplications, and so on. As you can see in this table, like they consist of like a very unique flops and memory traffic, so which would eventually give us like a better understanding of how to use this OpenMP offloading programmability options to achieve like a better performance compared to low-load programming such as CUDA and so on. So we say here CUDA because we tried this experimental setup on the NVIDIA GPUs. So CUDA seems to provide like a very good performance, such as compared to other low-level programming models. So that's why we compare the OpenMP programming model against the CUDA. There have been like lots of studies have been conducted on this OpenMP offloading, but most of the time, either they just talk about like discuss about like a very specific things, just like a compiler-based performance analysis, or highlight like a few things and so on. But we haven't found anything completely like a thorough analysis what we have presented in our work. So this is what we would like to present something that has not been like discussed or researched before in our research work. So when we do this GP programming, so when we say like GP programming, like typically we refer to like offloading the computation to the GPUs. So when we offload the computation to the GPUs, two main criteria should be considered. One is like a data movement, and the second one is parallelization efficiency. So data movement means like how efficiently you can move the data, because if you move the data like in a very bad manner, such as like not like an efficient way, then you might lose like lots of time. You might create like lots of overhead, which would like degrade the entire performance of the entire computations and so on. Once we move the data to the GPUs, of course, at the same time, we also want to make sure that like how efficiently we can do this computation on the GPUs. So in GPU programming terminology, there is a term called like a kernel computations. So basically, like how efficiently you can do this kernel computations, because the GPUs are based on this SIMD architecture, which is very similar to SIMD architecture that we see in the CPUs. So SIMD means like a single instruction, multiple threads. So Since the GPU can support like many threads in parallel, so we can achieve like a higher throughput and so on. So that is the idea. So basically, whenever we do this GPU computing, these are the main criteria: these two, data movement and parallel efficiency, which should be considered. So this is what we analyzed in this OpenMP offloading for the blast routines against these CUDA versions. In the experimental setup, we have used this NVIDIA Ampere A100, which is based on this Ampere GPU. So NVIDIA GPUs are based on these microarchitectures. So they name it like, such as in this case, it's Ampere, and then the successor of Ampere, it's Hopper, and then so like this. So each and every GPU, they have like a very unique features, such as like they support like a compute capabilities. For this one, it supports like a 8.0. Each and every compute capability, they provide like a enhanced performance in terms of like thread accessibility and things and so on. So as you can see here, like this as the table here, it provides like up to like 9.7 teraflops peak performance, and then memory bandwidth is like 1.55 terabyte per second. And then GPU memory is like 40 gigabytes, so we can do the operations, offload the data up to like close to like 40 gigabyte, and then we can do this computation on the GPUs. So in order to measure the experimental values, because we run the many simulations on using just a single GPUs, so we wanted to make sure that like because if you run the GPUs continuously, of course it might get like overheated. Of course, in the cluster we have like a cooling system, but in order to make sure that like we maintain the GPUs such as like 39 degrees Celsius or below, so that like it does not produce any computational errors and so on. For the fair analysis, we have used data up to like 40 gigabyte memory, and then also we use this double precision float values, because that is quite common in scientific computing to get these accurate results and so on. So we have implemented all those 4 blast routines, both for the CUDA and OpenMP offloading. Our contribution is like we examine like a kernel capabilities of the OpenMP offloading, because if you do not do this proper kernel efficiency, we cannot compare, we cannot analyze how efficient our implementation. Of course, we also evaluate like different data movement between the CPUs and GPUs, because OpenMP offloading provides like various APIs which can be used to offload the data between the CPUs and GPUs. And then finally, we also compare our best OpenMP offloading versions with the CUDA best versions. We don't discuss so much the CUDA implementation, because the CUDA implementation has been discussed in the past decades very well. So we just take these best CUDA implementations, and then we compare with our OpenMP offloading versions as well. And also in our work, we also provide this code snippets, plus also we also provide the code for this reproducibility in the research community. All right, so I will begin with this data mapping or data transfer between the CPUs and GPUs. So as I discussed before, two key criteria. One is data movement, and then the kernel computation. So the data movement is very, very key in order to achieve this good performance. So OpenMP offloading provides like up to 3 concepts of this data movement. One is like structured data mapping, and second one is unstructured data mapping, and third one is like data mapping using low-level APIs and so on. In the picture you can see in the right-hand side, it's based on this structured data mapping, which is quite easy to use. I will briefly explain those things in the coming slides. So OpenMP itself, it's very easy to use as long as we have a good understanding of this parallel programming. So when someone wants to do like OpenMP offloading to use the GPUs, OpenMP offloading APIs provides like a very simple APIs which can be used very easily, and then offload the computation on the GPUs. You can do the very easily. You don't need to learn like such as like a very low-level programming such as CUDA or OpenCL or SQL or things.
Sorry to interrupt you, but you have 2 minutes to conclude your presentation.
Yeah, okay, sure. So we don't need to spend too much time. So again, the unstructured data mapping is also very easy to use, but it still has like some kind of like overhead. So this is a difference between the structured data mapping and unstructured data mapping. As you can see in this code, structured data mapping, it needs like a very less code, whereas unstructured data mapping needs like a little bit more code, but it provides like a little more flexibility in terms of like a data moment computations. So data level, low-level mapping is very similar to low-level programming such as CUDA, which provides like a much control over this data movement, which enhances this computational performance. Plus also using the device, we can also mention like which, because in a compute node, we have like more than a single GPUs. So using the device, we can precisely point like which GPUs do we want to offload the computations. And also we have also device pointer to make sure that like the pointer are properly used in order to avoid any memory issues or wrong memory access during the computations. So this is a code snippet that provides like how to use this low data mapping to support this computation. This is the code blocks. So CUDA provides like as I mentioned to you, CUDA is based on the similar architectures. So in order to equivalently compare with the CUDA, OpenMP offloading is also provide like these compute blocks. So as you can see here, like a number of teams, thread limits, and then teams distribute parallel and so on, which contribute like a very equivalent to the CUDA, as you can also see in the table. At the end, in the total, we get like 36 and 36, which would give you like eventually like a close performance against the CUDA implementation. So now I'll go through this programmability options. So here we can see like we have concluded like two options. The option one is like very straightforward to use, but yet it's based on this low-level programming options from the OpenMP offloading. Option two, it's manually controlling the thread block because most of the time compiler chooses the best thread block, but as a programmer, you have opportunities to control the thread blocks manually. So we have analyzed all those options into thread blocks, and also, as I mentioned to you, like option two, because we want to include our manual thread block to control this computation efficiency close to the CUDA. So we chose like two options, like 2A and 2B. This is the numbers you can see. So for the CUDA approach, we have used shared memory options, which is quite common to achieve this good performance. Otherwise, we might not get like good performance and so on. For the OpenMP offloading options, we have used all those options like option 1, option 2A, and so on for all those vector dot product, vector additions, matrix vector multiplication, and so on. So here you can see this code snippet between these two options to see the comparison. Here also we have vector addition. Again, the CUDA provides like the shared memory. Of course, NVIDIA GPUs also provide the shared memory, which can be used in CUDA. Whereas in OpenMP offloading, we don't have this option, such as like using the shared memory, but we use all those options that I presented to you before and so on. This is a code snippet for the vector addition, and this is a matrix multiplication. Again, we use this shared memory, set the block size to get this best performance so that it can be compared again this OpenMP offloading our approaches and so on. This is a code snippet that shows like between the matrix vector multiplication. This is a matrix multiplication. Same also, we use this best approach for the CUDA, and also we have used different approaches.
Please conclude your presentation within 1 minute.
Yeah, sure. I will do that. Thank you. This is a code snippet that provides the difference between these methodologies and so on. So here you can see the kernel computations because we just want to make sure that like how efficient our kernel compared to these CUDA versions. As you can see here, vector dot product and vector additions are very close to these CUDA implementations, different approaches. Again, here as well, you can see that matrix vector multiplication is also very close to the CUDA versions, whereas matrix multiplication, CUDA is a little bit like efficient compared to other OpenMP offloading methodologies. It is mainly because the CUDA can use like a shared memory very efficiently compared to this OpenMP offloading. That's a reason. Of course, at the same time, also we want to measure like a difference between the data, high-level data transfer and low-level data transfer. So this table, it provides you like using the low-level API from OpenMP offloading provides like a best performance. So we measured for all those vector addition, other options as well. finally, you can see here is the overall performance. As you can see here, like almost we for this vector dot product, we get the very same performance as a CUDA using this OpenMP offloading 2P. Vector addition, we get this also close performance in CUDA compared to CUDA. Matrix vector multiplications also we get this very close performance. Whereas when it comes to like matrix multiplications, matrix multiplications, we get like something like a low performance, twice as low as CUDA. So as I mentioned it before, it's due to these shared memory issues and so on. Limitation I will skip. Conclusion and future work. OpenMP offloading shows a performance comparable to CUDA with some notable differences in certain tasks. Of course, OpenMP offloading lacks the shared memory capabilities where CUDA can easily utilize, get a good performance. Although there are some differences, but most of the time it's very identical to the CUDA implementations. Using the manual control thread, it provides like an even enhanced performance compared to CUDA. Of course, the default compiler, it chooses the best options, but using the manual thread block, it's also provide you like a better options, better performance ability. Using the low-level API for the data transfers, it provides best performance, very equivalent to the CUDA. So this is also very good findings. Of course, using the high-level API for the data movement, it's quite easy to use, but we have to compromise the performance. In the future, we would like to use this approach for the AMD and Intel GPUs because the GPU market is like very diverse, plus also the computing platforms, they have like a different architecture. So therefore, OpenMP offloading can be also used on the AMD and Intel GPUs to get the good performance, so that we can have like a single source code can be targeted like different architectures. So we don't need to like rewrite the code for the different architectures and so on. So thank you so much. So we would like to thank the HPC machines that have been used, and also the Eero HPC for the providing computational performance. We also conclude that there is no conflict of interest. Thank you so much.
Thank you so much for your presentation. Ma'am, do you have any questions?
Yeah, I have a question. Thank you for your very detailed presentation. And I have one question. Do you think that with the for the new GPU architecture like ADM, can OpenMP will maintain the similar performance?
Yeah, so thank you so much for the very good question. So although we say like GPUs like AMD, Intel, and NVIDIA, somehow they slightly differ with the architecture, plus all the compilers that are used with the different architectures. For example, in NVIDIA, we use this compiler from NVIDIA HPC SDK, which is commercial compiler from NVIDIA. On the AMD, of course, we can use like either Cray compiler or AMD compiler, which is based on like ROCm, ROCm compilers. I don't expect to. I've been doing already some experimental test cases. We cannot expect to have like a very similar performance as we do in the NVIDIA. Because on AMD GPUs, we cannot use the CUDA. We have to use the HIP version, which is very similar to the CUDA. So what we can do is that like we can compare HIP version against the OpenMP offloading on the AMD GPUs and so on. So that is what we can do. But I cannot promise you that we can get the same performance as we do in the NVIDIA GPUs and so on, because the architecture is completely different compared to NVIDIA or AMD GPUs and so on. Because in the NVIDIA GPUs, we have like this streaming multiprocessors and then compute graphical process clusters and so on, whereas in AMD GPUs you have like it's based on this SIMD length and so on compute units, which is slightly different than the NVIDIA GPUs. So however, the good news is that like we don't need to change the code so much. Having the single source code can be used on multiple different architectures and so on, which is very good news. So in that perspective.
Okay, thank you so much. I don't have no question anymore.
Yeah. So do you have any questions?
Yeah, I'm good. That's a very good work. Actually, the presentation. Very smart work. The thing is, the same source code can be used for multiple platforms. Will there be any challenges regarding technical feasibility with that regard?
No, sir, there won't be any challenges because it's a very good thing. Because as a researchers, let's say like someone is working like in a machine learning or a computational biologist or a computational fluid dynamics or astrophysics and plasma physics and so on, like a research scientist, we don't want to focus so much time on like fine tuning the code for the different architectures. We just want to have like a single source code that can be used on the different architectures, different GPUs and so on. So there are like different multiple options, such as like you have like a CUDA and a heap and then OpenACC and then a SQL, many languages. But OpenMP is being there for like many years, along with the MPI, which is for the distributed memory programming. OpenMP is for like for the shared memory programming. So most of the scientific codes that has been written like in the past 20 and 30 years based on this either OpenMP or MPI. So just introducing this OpenMP offloading, all those existing code can be easily targeted to these different architectures, spending like less time and so on. So that is a very good news. If you have like a CUDA code, of course, we have to convert this CUDA code to the HIP version or some other versions to target like a Intel or AMD GPUs. Whereas if you have like just like OpenMP code, which can be easily targeted to any kind of like a different diverse architectures. Of course, there could be like some performance differences, but that would be like a very minimal. So the time that we spent to rewrite the code or convert the code and so on. So yeah.
Right, perfect. Thank you very much. Appreciated.
Yeah.
We can proceed to the next presentation.
Thank you so much for your presentation. So we'll
Thank you
move
so much.
to the next presentation now. Next, we have Yuri to present the paper titled Design Principles of Consulting Computing System for Development and Adoption of Effective Management Decisions by Territorial Administrators. Are you there?
Yes. Hello.
Yeah, you may please begin with the presentation.
Try to. Can you see my screen?
Yeah, we can see your screen. You may please start.
Okay. Yes. Good morning, good afternoon, good evening, everyone. My name is Yuri Zontov. I am a junior researcher at the HEC University Moscow, Russia. Today we'll be presenting our work entitled Design Principles of a Consulting Computing System for Development and Adoption of Effective Management Decisions by Territorial Administrations. So the tasks of territorial administrative bodies often require development of a strategy for identifying priority problems, taking into account also the limited financial resources, which lead to a solution which will satisfy the interest of citizens in an optimal way. In our work, we're developing an electronic consulting information system which implements various mathematical models of criteria aggregation and methods related to the support of managerial decision-making by territorial administrations. Such a system will make it possible to detect problem situations, so-called bottlenecks, in ensuring the quality of living of population and to form a tree of management goals. The quality criterion is the satisfaction of an individual obtained on the basis of a threshold assessment. When choosing the architecture of the information system under development, we prefer the classic three-tier client-server architecture with a thin client, since it fully meets the requirements of the task being solved. The web application which is being developed is inherently cross-platform. The user communicates with the system via a web browser, which is available on all modern platforms. We also select technologies that are most suitable for a particular subtask. For example, the administration component is developed using the ASP.NET Core MVC platform, which provides many convenient ready-made solutions for web graphical user interfaces. For example, the cartography component, which will be describing in more details later, is developed in JavaScript, as it should provide the presentation of interactive maps in the user's web browser. And the algorithmic components are being developed in Python due to a large number of mathematical libraries available. Let's go next. So the system is being developed for modeling the quality of life of the region's population, with detailing at the level of municipal districts and cities. And the system involves support of decision-making based on human-machine interaction, the calculation of indicators based on formulas previously derived and coded by subject matter experts. So we are using hard modeling instead of a machine learning approach. The functional scheme of the system is presented on this slide. The analytical modeling unit is the general complex tool for performing analytical and modeling tasks. It coordinates the functionality of the system. The situations analysis modeling and scenario analysis unit perform the analysis of the current situation using the parameters obtained from the subsystems. It also creates the aggregated parameters and estimates the dynamics of the quality of life indices and performs the modeling. The system implements a set of models for territorial analysis of indicators of the quality of living conditions of the population. Models are implemented using indicators of various levels, both initial and aggregated, and also provides the scenario analysis. The system implements the following databases. The database of territories and districts, cities, and settlements, specific to administrative unit. Also, a database which contains the hierarchy of municipalities. A database of indicators, which contains 3 sets of indicators, such as initial, aggregate, and indicators of the quality of living conditions. And foremost, the initial indicators are being collected by the staff of the Yakutsk University through request to the relevant responsible regional authorities. And the aggregate indicators are being estimated based on the models and the initial indicators. The database also contains a list of years for which the data is available and the list of scenarios. The system implements the following functional models: the data editors, a set of data editors, which allow to edit the values of indicators, the list and tree of indicators, the list and tree of territories, because both of them are organized hierarchically in the database, and provides also options for copying and pasting of the indicators, as well as uploading and downloading the data in the text formats. The data visualization in the form of cartograms, charts, and various infographics, as well as tables. The evaluation of parameters, which includes the models for estimation of indexes of quality of living conditions and also of aggregate indicators, and various tools for preparation of reports, such as export of cartograms, tables, and diagrams. The system involves the following operations with data and analysis. The first step, the initial indicators of municipalities are being analyzed and the models are being adjusted. Then the database of the current situation is being filled in, consisting of initial indicators of the quality of life of the population with details by municipalities. Then the current situation is being assessed with a calculation of aggregated indicators, which are being grouped into blocks reflecting the quality of the work of the regional subsystems, such as access to education, medical care, transport accessibility, quality of housing, development of the service sector, and so on. Several blocks of scenario analysis are being provided in the form of such that the user may provide a new set of the values for the parameters, and the system will assess how this change in the initial parameters will affect the quality of living of the population. And also the analysis of priorities. The development scenarios are generated by making change to the values of aggregated indicators, and indices of the quality of living condition in a municipality are calculated and analyzed which of the blocks of indicators provide the greatest contribution to improving the quality. Also, the socio-economic data visualization is an essential component of the software suite. It allows the user to interpret and analyze complex data through intuitive, interactive graphical representations. And so the visualization engine uses the capabilities of D3.js and Topo.json libraries, and is being developed in JavaScript and interacts with other parts of the system via the REST API. The main features of this component are the palettes. So the coloring of regions and the generation of the legend are selected in accordance with the type of visualized indicator.
Sorry to interrupt you, but you have 2 minutes to conclude your presentation.
Thank you. Also, the pan and zoom, so the user may select the subregions of interest. Temporal analysis is implemented in such a way that clicking on a feature displays a time series graph of the selected metric, allowing users to analyze trends and changes over time. And also the tooltips hovering over an object displays detailed information, the name and the name of the selected object and exact value of the selected indicator, as well as additional metadata. And also tabular data view is available, which displays a table with a list of cartogram objects with corresponding values of indicators. To conclude, the task of territorial administrative bodies are so diverse and variable that their solution requires development of a strategy for identifying priority problems in condition of limited financial resources, the solution of which optimally satisfies the interest of citizens. And the system being developed is designed to become a convenient and a powerful tool for analyzing the level of development of the region, scenario analysis, supporting planning, and making high-quality management decisions by the regional officials. I would also like to thank the Russian Scientific Fund for continuous support of this research. And thank you for your attention.
Thank you so much for your presentation. Ma'am and sir, do you have any questions?
Yeah, I have one question.
Yeah.
Do you where you can get the data, and how can we ensure that the input data is reliable and up to date?
Right. So to make sure that the data is up to date, we are contacting with, as it was mentioned on this slide, that the data is provided by the staff of Yakutsk University. So Yakutsk is the main city of the Republic of Sakha, Yakutia.
And have the system been tested in any local area?
Right. So the system we are developing now is, as I mentioned earlier, it is a web-based system, but our team earlier was developing like a desktop version, which was successfully tested on other regions, both in Russia and in other countries. So in this system, we want to make the next technological step to make the system web-based, cross-platform, and more available to the users. But the algorithms have been tested, yes.
Yeah, thank you so much for your presentation and answer. Yeah.
Thank you so much. So, do you have any questions?
Yeah, I think we can proceed to the next session. My only concern is, whenever the presentations, please spend more time on your contribution, avoiding quickly the introduction stuff kind of thing, so that the audience and the many people will learn more. It's a wonderful work, highly appreciated. Keep going. Thank you.
Thank you.
Thank you so much for your presentation. So now we'll be moving on to the next presentation. Next, we have Wifeng to present the paper titled Development of Comprehensive Framework for Detecting Insider Threats. Are you there?
Yes. Do you hear me?
Yeah, we can hear you. You
Okay,
may
great.
please begin.
Okay, I'm gonna share my slides over here, which is over here. Sharing. Okay, do you see my screen?
Yeah, we can see your screen. You may please begin.
Okay, great. Let's see. Okay, so my title is development of a comprehensive framework for detecting insider threats. So this is like overview work between my student Sunday and myself, and I'm faculty from the Department of Computing and Engineering Technology at the Penn West University of here. So again, so this is like a review paper. Hopefully, our goal here is to increase the people awareness of insider threats. So we are going to begin with why we're going to do this work over here. So let's begin with some data showing how serious the insider threat attack right now in the at least in the US over here. So as you can see over here, the insider attack have been spiked by 47% over the past 2 years. So they keep increasing. And another reason is insider attack is difficult to detect because they are the attack come from the inside. So as some Chinese saying of here is the most difficult thief to detect is from your inside or from the inside. So that's what we're going to see over here. And then there are some other data showing that annually the average cost of the insider threats is almost $11 million, and this number is increasing every day, every year of year. And in the global average cost of insider threats is about $15 million. So those data are showing that now it's very important to look at these threats over here because the damage, the cost is so significant that we cannot ignore this kind of threats over here. And then only 42% of the company have the needed system to prevent an insider attack, What they mean over is over half of the company, they are not aware of this insider attacker. Not to mention they have the system to detect prevent this kind of insider attack, and that's the reason we want to improve or either increase people's awareness that insider attacks very serious, and then we need to start from today. We need to do some work. We need to do something to detect or either prevent this kind of insider attack of here. And the next one over here is the most common type of insider threat. It's called data exfiltration. So as 62% of the type of insider threats come from this called data exfiltration. And we're going to see what is data exfiltration. And I'm traveling, so the internet connection. So so the next one, the last one here is the negation. Negation accounts for over 2/3 of the insider threat incident, which means people, they are not aware. Okay, they don't pay attention to that. They don't, okay, everything is fine, everything is okay, but actually the consequence is pretty bad of here. So we're going to improve again. We're going to improve people's awareness of this kind of insider attack or insider threats of here. So the outline of this presentation, we're going to introduce what is called insider threats, insider attack, and then another Chinese saying over here is, if you want to know the enemy, we need to know the enemy well in order to defeat enemy. So we need to know what the methods or strategy of the insider attack. We're going to understand how the enemy work in order to detect, in order to prevent or either defeat them over here. So we're going to see the methods and the strategy of the insider attack. And the next one, I'm going to understand the nature of the insider threat in order to do a better job to detect and also prevent insider threats over here. Then the next 3 bridge over here, we're going to see, okay, how can we, in general, how can we detect and prevent the insider attack? And then we're going to, how can we improve insider threat awareness so that everyone understand the importance or either the significance of these insider threats, so they can do something to prevent or either to detect them. And finally, we're going to see like an insider threat program, we call ITP. How can we, what components of this insider threat program to, in order to detect, in order to prevent this insider attack. And finally, we'll conclude this presentation. So again, the purpose of this presentation is to improve the people's awareness of insider attack. So we can, starting from today, we can realize that the significance of this problem, and then we can do something about that to prevent the damage of this insider attack over here. Okay, so let's begin with the introduction. So what's insider? So we call insider threats. So what's insider? Insiders are individuals within our organization because they call insider, but they also have some, they have the access to some, we call sensitive information and the system. If the information is not sensitive, nobody care about that. But if the sensitive information, the information is sensitive, then we need to, the information is valuable. For example, there are some maybe some business information, credit card information. Those are sensitive information. They are valuable, and then people, some insider trying to sell them for benefit, for profit, or either they want to disclose to somebody else for money or for some other purpose of here. So what are the example for the insiders? For example, they are privileged users. They have access to some information. Maybe they are the system administration, or maybe they are the account manager. They know they are privileged user. They know they have access to the sensitive information, and they all could be also like contractors, because today some of the software have been outsourced to some other company, which they call the contractor. So they have access to those data, and then or either the third-party vendors. So today the internet is like all integrate different kind of system. Like a Walmart, they may have some third-party vendors. They order the information, they order product from the vendor. They have all their maybe they using the third-party vendor to sell the product to the customers. So which means the third-party vendors also have some sensitive information of, like, for example, the Walmart's customer information, and even the business associates. Those are all the example that who could be an insider. Insider are the in general are the individuals with has access to the sensitive information, and maybe they could disclose this sensitive information for personal purpose, or for either for money or either for some other purpose of it. And the data showing that the nature and the scope of the insider threat has significantly changed because of the we call cloud infrastructure of here. So today we know that the cloud is everywhere: personal use, business use, or the AWS, Amazon service, or either some Google cloud, all those, or either iCloud. All those cloud infrastructure is the trending of here. Everyone use cloud of here, and the reason the consequence of the using cloud is information are everywhere. So if Walmart have all the cloud infrastructure, that which means all the Walmart's customer information are everywhere. So which make the more the scope, or either the potential attack surface of the Walmart information broadened. Original maybe they're only in the Walmart system, but now with the cloud infrastructure, they are everywhere. Then if they're using Google cloud, then again they have the Google account potential of there.
Hi,
If
are
they're
you
using
on
another,
the introduction slide or are you moving your slides?
I still in the introduction
Okay, great.
slides of the
You-
yeah. Okay, thank you. Yeah. Okay, so there are some data showing this extent. So for example, in 2017, there's 50,000 clients information exposed by Wells Fargo. Wells Fargo is like a famous bank in the American of here. And another bank they because they're bankrupt because they lost of 1.4 billion dollars because of the internal security incident. So if you have an insider threat, the consequence is pretty huge of here. And in this paper, we focus on the retail sector because the retail sector, we think maybe the potential points of vulnerability is very big, because retail sector, they need to interact with different third-party vendors. They spread across the numbers of stores and also distribution centers, and they also frequent interaction with the third-party vendors. Again, as the Walmart example, they use different kind of maybe the deliver distribution center. They outsource this functionality to the third-party vendor. So they have the third-party vendors have the information of their customers' data, and there are frequent interaction. Everyone places the order, then go to the third-party vendor, and this kind of interaction are pretty frequent over here. So the problem statements of here is that we need a proactive insider threat program because it's so important. And what is the proactive insider threat program? There are 4 components of here. First, we need to identify the sensitive data, and then we're going to extend. First, we need to identify what data need to protect, and then trying to protect those data. Second, we are going to extend to the sensitive systems that could be potentially impacted by the malicious insider, because those are target of the insider threats of here. And then identify the target areas for the malicious insider. And last, we're going to propose some methods to explore and also protect such target areas. So find the problem, identify data, identify the area, and then trying to protect those areas. So those are the general approach to prevent the insider attack of here. So let's understand how the insider attack work of here. As we mentioned in the first slides, 62% of the type of the insider threats are called data exfiltration. So very common threat. You can very easy to understand this. It's like called unauthorized copy or transfer, or either retrieve data from the company to their outside
Sorry to
company for personal
interrupt you,
purpose.
but you have 2 minutes to
Uh,
conclude your presentation.
Only 2 minutes? Okay, I will be quick over here. Yeah, so for example will be unauthorized. So I'll think I will use this example that in a house we have some valuable information. So if I'm working the house, I can personally steal the information off here. That's called data exfiltration. And the approach very obvious. We have cloud storage system. I copy the data to the cloud, and then when I go home, I download the data from the cloud of there. So the damage of this insider threats, pretty obviously, the data I can sell data. I can maybe introduce some ransomware software out there, or I can introduce the code bug in the software. And sometimes I can establish the backdoor access of here. So nature of the insider threat of here, 3 different kinds of insider. Malicious, intention, I'm going to steal something. Negligent insider, I don't care, I leave the door open, everyone can come into the house to steal something. compromised insider. I work with someone else. I work with the threat, the thief over here, so together we can steal something out of the house over here. So to detect and prevent the data, we propose that there are these 7 approach people can use to detect and prevent the insider threats. First, the data loss prevention, endpoint detection and response, user anti-behavior analysis and cloud access security broker, intrusion prevention system, and firewall policy over here. And the second step over here is to improve insider threat awareness. So all this approach over here can help the organization to either use training or either education to improve their threat awareness. So we're going to do something better starting from today to prevent this insider threats over here. So about the insider threat program, we are going to focus on the retail environment, and the purpose of here is to safeguard sensitive data, such as credit data or the employee PI called personal identifiable information. So the goal here is to safeguard and approach, as we mentioned previous over there, we're going to identify the data, and then we're going to integrate different kind of tools, and then foster a culture, as mentioned. If everyone are aware of this potential threat, we can do something. We can work together. We can work starting from today. We can prevent this data. So foster culture is also important. And finally, promote the vigilance and also report suspicious activity of your challenge. Limited financial resource balance, and also the balance between the risk and also the potential impact. And then finally will be financial deliberation. Sometimes there are some cost and also trade-off over here that the company may need to pay this cost in order to prevent future attack of here. So last, to conclude of here, as you mentioned, this is like a review paper trying to improve people's awareness of the insider threats. We look at some data showing that insider threats are pretty significant. The damage are huge. So there's definitely a need to extend this kind of this ITP over here, and we just basically propose a very simple solution to prevent this insider threat over here. So that's a quick presentation about our simple work over here. Any questions? Thank you.
Thank you so much for your presentation. Ma'am, do you have any questions?
Yeah, thank you for your presentation. I consider I have a question. That how is the cyber skill chain framework can tailor with the retail industry? And
Okay, yeah, thank you for the very good.
Okay, you can answer.
Okay, so yeah, thank you for the very good questions. So as I mentioned, retail systems are very challenged because retail, they are first they are compared to some other company, they are everywhere, because if you think about retailer system, they need to reach out all the potential customers no matter where they are. So they compare to some other company, retail systems more challenging because their coverage is more compared to some other systems. So which means they need to have more. They have more interaction with the third-party vendor, so there are more potential vulnerability point they need to look at. So that's the change about the retailer system compared to some other company. If I'm just like a school, then only my focus only my school over here. If I'm a university, my focus only my university. But if it's a retail system, my customer could be everywhere. So that will pose some potential vulnerability point to my system. So they will increase more challenge compared to some other system. If you look at the cybersecurity thing of here, there are more point or either more place to protect compared to some other system of there.
Yeah, thank you so much. Yeah, I have no question anymore.
Sir, do you have any
Okay,
questions?
thank you.
Yeah, I'm good with the presentation. I just have a question regarding the university. Is it the Penn West University part of Penn State University, or it's a different one?
Yeah, so the great question. So this is we used to call California University of Pennsylvania. That's even more confusing. So a couple of years ago, we integrate with another 2 campus. So we're now it's called Pennsylvania Western University. So it's different than Penn State. So we are 2 separate systems compared to Penn State. So the Penn State is like the state founded university in Pennsylvania, and we have another system called PESHI, which is public Pennsylvania Association of Higher Education, and we have 14 campuses across the Pennsylvania. So this Penn West, there are 3 campuses on the west side of the Pennsylvania near the Pittsburgh area. Thank you.
Good, thank you for the clarification. In fact, we were in 2018 at Pennsylvania with Amit and the GR Foundation members and all that. We were there in the
I
state.
see.
So
I see.
I just wanted to.
Yes, I understand.
Thank you,
Yeah,
thank you. Good work, good presentation.
Thank
Thank
you.
you so
Yeah,
much.
thank you.
Thank you so much for your
Okay.
presentation. So we'll be moving on to the
Okay.
next presentation now. Next, we have Shahab to present the paper titled ECT-DLM, Deep Learning Based Empirical Correlate Transform Approach for Thoracic Diseases Diagnosis for X-ray Images. Are you there? Shahab, are you there?
Yes, I'm there. I
Yeah.
just need to share the screen first. Just
Yeah,
give me a
you may
second.
please.
Hopefully you can see my screen now.
Yeah, I can see your screen. Oh, it has started sharing.
Okay.
Yeah, I can see your presentation. You may please start.
Okay. Good morning, everyone. By the way, I'm in Australia, and today the time is 12 night time.
Appreciated.
Thank you so much. The title of my presentation is Deep Learning Based Empirical Curvelet Transform Approaches for Thoracic Disease Diagnostic from X-ray Images. I just need to keep the slide here. The outline of my presentation will be introduction, methodology, and model development. The methodology will consist in different parts: data sets for X-ray analysis, two-dimensional empirical curvelet transform, ECT, dense net model, performance evaluation, experimental results, which is consists of comparison with the other deep learning models, and the last part is the conclusion. The introduction of my presentation: lung diseases including pneumonia, lung cancer, and continue to affect millions of people globally. A chest X-ray classification is a general radiological assessment using the identify lung and heart diseases. However, reading the X-ray by expert needs high knowledge. As a result, it is significant to design X-ray image classification model support clinicians or experts. Recent developments in deep learning based on X-ray images have provided new methods for diagnosing lung diseases. Conventional neural networks have shown significant success as a powerful methodology in image classification. In this study, we develop an intelligent method for X-ray classification. Despite more recent models have been designed, interpreting X-ray images remain a challenging for the expertise, as a time-consuming for radiologists designing more accurate mode and help and support radiologists. Much research has been designed to classify X-ray images. For example, Yao et al. In 2017 applied a long short-term memory for diagnosing lung diseases. The main reason for using LSTM are that they are able to capture sequential features in data. In this paper, we designed a new model to classify X-ray images we integrate the empirical dense-net techniques with a curvelet transform to propose a model was tested with a public data. The methodology and the model development, as we can see in figure 1, the section described the proposed model used X-ray classification. The empirical curvelet transform is used to analyze X-ray images. Then the output of the ECT are sent to the dense-net techniques. The proposed model consists of 3 phases: analyzing X-ray images using ECT, classification using dense-net, and evaluation phase, as I mentioned in figure 1. Data set for X-ray analysis, we used in our paper, a total of 30,805 subjects were involved in collecting X-ray images. All collected images were labeled to one of the 14 common theoretic pathologies. These labels derived from associated radiologists. I have difficulties to pronounce radiologist. Reports using natural language processing, enabling multi-label classifications where each image can correspond to a multiple disease. The 14 pathologies include number of diseases and for the lung diseases, and you can see number of these diseases are listed here. Due to the privacy concern, the original radiology report linked to the X-ray are not publicly available. The text mine label boasts accuracy exceeding 90%. Young et al. In 2019, figure 2 show 8 example of the lung disease, and you can see that in this figure 2. You can see the difference between these diseases. The two-dimensional empirical curvelet transform is powerful model designed to analyze data. It has been developed to analyze multi-dimensional model and capture important features. ACT is designed based on the concept of curvelets. It decomposes signals or images into a frequency component at a different scale and offer localized representation for both frequency and spatial domains. This allows accurate features extractions. Several studies have been shown that ECT is superior to wavelets and fast Fourier transform in processing curve structure. As a result, it's useful in edge detection and feature extraction. It's also provide more impact interpretation for texture analysis, improving medical image analysis application. The ECT was used to analyze medical signals. It contains 2 stages. First, the ECT separates the Fourier spectrum into N chains using a filter bank. Then it uses a filter bank to filter the input signals to extract different elements. The filter bank used by ECT includes N wavelet filters. One of low-pass filters refers to the approximation, while the other N-1 represent the detailed components. DenseNet model. In this research, we employed DenseNet to classify the X-ray images. The main architecture of the DenseNet model is presented in figure 2. As I showed this figure 2, you can see different type of diseases or lung diseases. It's constructed from following parts: conventional layers, maximum pooling, and BN layers, and input layer, and the dense layers. Conventional calculations were made via the conventional layers on the input data using the kernel filter, while the data standardization layer performed the fostering generalization. In addition, the maximum pooling layer is used to prevent the overfitting problem. The dense layer is responsible for the feature extractions. The DenseNet techniques involve 3 fully connected layers with 3 multiple scale blocks. Performance evaluation, we used several statistical metrics in this paper. The design model was assessed in terms of the frequency score, specifications, accuracy, and sensitivity and precision. And you can see the equation of the accuracy, sensitivity, and precision is provided in this slide. The experimental results. The obtained results were discussed and reported in this section. To assess the efficiency.
Sorry to interrupt you, but you have 2 minutes to conclude your presentation.
I will finish in 2 minutes. To assess the efficiency of the design model, several metrics were employed to perform evaluation. The data set was divided into testing and training set to ensure the stability of the results. The proposed model was assessed in terms to accuracy, specificity, precision, and score and sensitivity. From the obtained results in figure 3, the proposed method gained the average of precision, F-force accuracy, specifically at sensitivities 96, 96, 95, 95, 95, respectively. The results prove the ability of the proposed model is categorize X-ray images into different classes. You can see figure number 3, the accuracy of these in very clear. You can see the quality of this accuracy. Comparison with the deep learning models, our ECT-based DenseNet model was compared with several deep learning methodology, and we can see that our model is achieving higher accuracy, 97 compared to the other models, 90, 84, and 80. And as I mentioned, the method we used is achieves 97%. This is another example to see the method we used is better compared to other methods. And the conclusion of my presentation in this paper, we designed a model X-ray image classification. The proposed model can enhance the quality of the medical image interpretation. The ECT was integrated with the DenseNet and was compared with the other deep learning models. Our finding confirmed that proposed methodology has the ability to analyze medical images. Lastly, compared the previous method, ECT with the DenseNet showed significant improvement compared to the other models. Thank you so much for listening and your questions.
Thank you so much for your presentations. Ma'am, do you have any question?
Yeah, thank you so much. I have a small question. I read in your abstract, does the model achieve an accuracy of 98%?
97.
But in the contract it's 98%, but in the presentation it's just 96, 96, 95, 95.
Let me see which slide you said. Which slide?
Not like I read in your abstract, your paper abstract, because I received the paper abstract and I saw that is very high accuracy, the 89%. So I think this is very good result. But here just 96.
96. If there's something in my paper, I will update that. That's the most updated one.
Yeah, just the most confused. And another question that is, do you have test the on the real hospital database? Sure?
Yes, we have the data for the real patient from the number of hospitals in Australia.
Yeah, thank you.
Yep.
And this is nice result, and it's a good result in your
Thank
paper.
you.
Thank you so much.
Thank you so much. Thank you.
Thank you. Sir, do you have any questions?
Yeah, did you use any benchmark data set? But because the results are too good to me.
Yep.
So what kind of data set actually you used for this? Did you use any benchmark data set to establish the efficacy of your system? Because this is something related to medical field and medical domain. So what data set you used for establishing the efficacy of the system?
Here you can see this is the data set we used.
Total 30,805?
Yes.
So from where you got the data set? Is it the benchmark data set that has been used for the other algorithms that you have compared?
We have agreement, the University of Southern Queensland, we have agreement with a number of hospitals in Australia, and most of the data we got from the Toowoomba-based hospital, and we got this data.
Sorry, actually, you did some comparative study, right? You did,
Yes.
you compared. So how did
Yep.
you compare? Did they use the same data set, what you used to establish the comparatively your system is better than the other systems?
Yeah, when we use the data and try to analyze, we look at the X-ray, try to use our method, and we can find the result we find it's 96%. Compared to the other result, when we through the literature, we can see that very clearly.
You show that image
This
one
is-
for me. That image.
Yep.
That lung image.
The-
Subjectively. Yeah, be there. So the data set for X-ray analysis, are these images, are the benchmark images? I mean, the algorithms, the systems that are in existence, did they use the same images, or did you just taken randomly?
randomly. This is just a sample, just one sample.
So when you took something as a sample, how can you establish a comparatively your system is better?
We divide the data to two parts: training, and we train the data 20% to 80%, and try to compare the data with the other researchers, with the literature.
Fine. However, Mr. Sahab, your work is too good to me, because we need this kind of research, and I appreciate your commitment. Though the late hours of your country,
Thank you.
well. I remember chairing in the midnights for some of the conferences. So I'm so happy that this is the fantastic time for us in India. It's coolly around 7:30. So appreciate it. We can go to the next presentation, please. Thank you.
Thank you.
Thank you so much for your presentation. So we'll be moving on to the next presentation now. Next, we have Elibis to present the paper titled Ensemble Deep Learning Models for DNA Sequence Classification, a comparative analysis of CNN, builds STM, GIU, and ensemble architectures. Are you there?
Yes, the afternoon. Let me try to share my slide deck.
Yeah, you can share your slide.
Is it visible?
Yes, it is visible. You may please begin with your presentation.
Okay, afternoon, those who are in the global south, good morning, those who are in the west, and then good evening, those who are towards the east. My name is Elias Tabane from University of South Africa. Today I'm presenting my paper on Ensemble Deep Learning Models for DNA Sequencing Classification. This is part of my PhD thesis, and it's an ongoing research which I've been carrying over, because I've done the first phase. I've got the result for the first phase. The second phase, this is the third phase, just to compare the overall of those results. Also, under here, it's my two professors who are my supervisor, who were part of this work. So the table of content is that we have the motivation of this research study. We're also going to look at the research gaps, which are also identified from the systematic literature review. We're going to look at the exploratory data analysis, the experiment itself, then we can draw a conclusion from those particular experiences. So the motivation of this study is that it addresses the critical gap. That is, the study identify a significant gap in existing research and aims to provide a new insight that contribute to the fields of advancement. Furthermore, we have the real world impact. So the research also is driven by the practical applications of this DNA sequencing, aiming to solve the real world challenges and improve the industry practices and the user experience, especially in this era of fourth industrial revolution, this era of AI, where we see large language models coming in. We see a lot of deep learning models also improving. So these improvements in these deep learning models are also contributing to this real world impact. And also the motivation will be to enhance innovation by exploring the novel approaches or the methodologies. Also, the study seeks to foster innovation and pushes the boundaries of the current knowledge. As you know, that this field of DNA sequencing, normally it was just meant for medical, but now because of the era of in the fourth industrial revolution, we see now it becomes the biotech, whereby the developers themselves, they're coming in with their expertise, trying to also shape up that particular conversation on that medical fraternity. So the phenomenal behavior or the
Sorry
problem
to
statement.
interrupt. Your slide doesn't move. Yeah, maybe you share another screen.
Let me
Yeah.
stop sharing. So we are on slide number 3. Let me share again. Just a minute, I will be sharing now. Is it visible now?
Yes, it is visible now.
Okay, let me continue from the current slide. So I was speaking about the phenomenal behavior or the problem statement that there is a lack of data accuracy and consistency when we're dealing with the DNA sequencing for human genomics and some other species as well. So the empirical situation which we are trying to solve here is that our situations falls under the smart health domain, which I said that it is part of the bioinformatics, whereby also technology coming into the medical fraternity and also trying to solve a lot of challenges which they are currently experiencing. Like the previous presenter was speaking about the lung cancer, somebody else can come in and check the heart diseases. So all of these empirical situations falls under the domain of smart health. So the aim and objective of our study is in this research is that this research paper seeks to address the issues of DNA sequencing and classification using the deep learning approaches. So the research gap identified is that there is interpretability challenges. Also, we have the data limitation and the generalization. So with the interpretability challenges, the deep learning models in the genomics achieve the high accuracy, but their lack of transparency makes it difficult to understand their prediction and also limiting the clinical adoption. So also the data limitation speaks to the training of the deep learning models, which requires the large, high quality labeled data set, which are often difficult to obtain due to the noise and the incompetencies in the genomic data. So the generalization issue speaks to the deep learning models showing promises in the specific genomic task by requiring further research to ensure that they generalize effectively across the different species, which I spoke about, the human and the animals, also within the flora, which is the part of our ecosystem. So also in this continuous research study, whenever we have this data, acquiring this data from the Kaggle open source, what we normally do, we don't just adopt this data set, but what we do, we'll also do the exploratory data analysis to check within that data if there are any missing values within that data set. And then also we do the data distribution, whereby we check the imbalances and the balances of our data before we can even train that same particular data. Also, when you do things like the correlation of the data. That's where you'll determine if within that correlation line, there are some outliers, the noise. So these outliers will tell you that there's something wrong with the data set before you can even try to implement it. So before we implement it or training it, it is best to do this exploratory data analysis to remove all of this data noise, to remove also the missing value or replace them with a zero so that it cannot give a false interpretation of our prediction. Also using the hyperparameters to tune the model so that we avoid overfitting and underfitting as well. Furthermore, in our data distribution, this is how the distribution of our data was formulated based on the attributes which formulate the DNA sequencing, whereby we see that 33% was allocated to the censuses, and then the IO channel was at 16%, and then the viruses was also at 16%. So all of this distribution, when it comes together, it gives you the 100% distribution. So that's where you can see how your data correlates, or if there are any imbalances within that
Elias,
data.
sorry for the interruption. Your slide is not moving at all. I think somehow there is a technical glitch there. You're at on the same slide, aims and objectives. Are you in the same slide?
No, I mean a data exploratory analysis. That means there is a technical glitch. Let me stop
your
and
slide remain the same.
Yeah, there is some kind of technical glitch from your
Yeah,
side.
some glitch is there.
Okay,
Yeah,
let me.
you run it again.
Okay, let me go to. Because I'm selecting the window and the window for presentation, but it surprised me
No
that.
problem, you can do that. Yeah, you share your screen.
Okay, so is it visible now?
Oh.
Is it visible, the exploratory data analysis?
No, your screen is not shared.
Yeah, that means there is a technical challenge, but nonetheless, let me do this. From this side, does it shows the exploratory data analysis?
You are not sharing the screen. We can just see the Zoom meeting on your.
Yeah, there is some. This is because from my side, I'm sharing. Let me do this again.
You can simply share the screen.
Yeah, so I'm clicking on the share, but it doesn't give me the option. So when I click, it gives me only this option, which you say
Now
it does.
you can now we can see the slide number 6. That is
Okay.
exploratory
So,
data analysis.
Yeah, now you run the slide.
so when I run it, it doesn't want to move.
Okay,
But
then
let
you
me
change manually. You change manually the slide. That's how you change manually. You select the next slide.
okay, no
Select the
problem.
next slide.
Yeah, just
It's-
click
it's-
and select manually. Yeah.
It's fine, Prof. Sorry for that inconvenience. So I was speaking about the exploratory data analysis.
Yeah.
That
Then you speak about the next slide. You please select the next slide. Okay.
yes.
Quickly, the time is running up. Yeah.
Yes, so with the experiments, the data acquisition, we also do the code download, that DNA sequencing data set of the human genomics and then we put it on the Google Drive. Also the data comes from the Kaggle, which is an open source. It has been benchmarked. Most of the guys are doing the research on that particular data set, but we took it a little bit further by also doing the exploratory data analysis, just to check that indeed there are no imbalances, there are no noise, and then also the hyperparameters are preventing the overfitting and the underfitting. And then also we did the split of 80-20 ratio when we do the training of that data set. So with the experiment, this assemble model, this is the confusion matrix of the assemble model. So the confusion matrix of this assemble model will likely indicate that an overwhelmingly high number of the true positive and the true negative, with the minimal false positive and the false negative, which further indicates that the model performed excellently in both aspects of the precision and the recall as well. So also we have the rock area under curve and the rock there. So with the rock, the best performance rock curve, which increasingly rapidly upwards to the left, top left hanging upper to the boundaries should be from the assemble model. This will imply that there is a very good discrimination of the model between the positive and the negative case and the difference threshold. So it's also with the area under curve, it is also moving towards this direction on the horizontal a curve which is also constant in that particular space. So we're looking also at the experiments. So within these experiments, we had the convolutional neural network, the
Sorry to interrupt
bi-LSTM.
you, but please conclude your presentation within 2 minutes.
Yes, I will do so. So we have these particular models, and then the accuracy score was sitting at 80.6, the 90.8, and then the 81.2. So with the assemble, it was just performing under this one with 90.6. But when you look at the precision, it also outperformed this entire three models as well. So when we go to the conclusion, this emphasized that the strong performance indicate that the assemble learning leverage the unique strength of the model in a manner that it increased classification accuracy. The performance also of the ensemble model holds a greater promises in the bioinformatics application. So in the future work, we will further optimize the ensemble approach and apply it to other biological data sets. So in the overall, this paper confirms that the potential of the deep learning in a DNA sequence classification opens up the avenue for further advancement and in the field of genomics. I don't know if there's any questions arising from Prof and the class as well or the group as well. Sorry.
Thank you so much for your presentation. Ma'am, do you have any question?
Thank you so much. I had no question. Please,
Okay.
Professor.
Sir, do you have any questions?
Yeah, I think we can proceed to the next presentation, please.
Okay. Thank you so much for your presentation. We'll be moving on to the next presentation now. Next, we have Endeavor to present the paper titled Hulls of Cyclic Codes over a Local Ring. Are you there?
Yes.
Yeah. You may please start with your presentation.
So let me share my screen.
Yeah. Yes, it is visible. You may please start now. Yeah, you can start.
Okay. Okay. Thank you. Hello, everyone. I'm Indivar Devnath from India, and I'm pursuing a PhD under the supervision of Professor Om Prakash. And this is a joint work with my supervisor. And first, I would like to thank the organizers for presenting this opportunity to share our work. So the title of our work is the hulls of cyclic codes over a local ring. So in particular, we have chosen a particular local ring ZPQ in this work. So this is the outline of my presentation. First, I will go through some basic definitions and results, and next I will move on to our main contribution part, where I will discuss on the hulls of cyclic codes over this ring ZPQ, and finally show some references. So first I start with this definition of linear code. Linear code of length L over this ring ZPQ is actually a submodule of ZPQ L. So you can see from these two conditions, it's actually a submodule condition. And here is one simple example of a linear code over Z3 cube in particular. Next, the dual code. Dual code is defined as the collection of all those members in this ZPQ L whose Euclidean inner product with all the code words J is equal to 0. Here we are considering only the Euclidean inner product, and this is one example, simple example, where in this particular case we have the dual code to be equal to the code itself. Here we call it the self dual code. Next, we have hull. The definition of hull is actually the intersection of the code with its dual. Here we have calculated, given one example where we have calculated the hull of a code, and it becomes equal to the code again. So in this case, we call, when the hull it becomes equal to the code, we call it a self-orthogonal code. So this is the definition of cyclic code on which we have worked. Cyclic code is a linear code whose if we for the cyclic shift of every code word is again a code word. You can see the cyclic shift of this code word A0, A1, AL minus 1. It becomes this. The last coordinate becomes the first coordinate, and all the other coordinates gets shifted to its right by 1 plus. This is one example. As you can see, the cyclic shifts are also the code words of this code. The cyclic shift for 400 is 040, and its cyclic shift is 004, like that. Next, this is the algebraic structure of a cyclic code. To discuss the algebraic structure, first we need this identification, where we identify a vector in ZPQ L with a polynomial of degree at most L minus 1 in this ring, in this quotient ring. And with respect to this identification, here we have this known result which concludes that a code J is cyclic, a linear code J is cyclic if and only this satisfies these two conditions, which are nothing but the conditions of an ideal. So this is how we can construct cyclic codes. If we get an ideal of this quotient tree, we will get a cyclic code. Next, we have a couple of definitions which will be required in our results. So first one is the reciprocal polynomial. For a polynomial fx, we denote its reciprocal by f star x, and this is its definition. This is how it is defined. And this is one simple example. For this polynomial, fx 4 plus 10x plus 2x cube, this is how we have we compute the reciprocal, where the coefficients get reversed actually. Now, the second definition is the basic irreducible polynomial. For a polynomial in ZP cube over ZP cube, we call it basic irreducible if it's irreducible over ZP when we take the coefficients to modulo P. Here is one example. We consider this polynomial fx, x square plus 14x plus 26 over Z5 cube, here P equal to 5. So if you take modulo 5, then the coefficients become this x square plus 4x plus 1. And this is an irreducible polynomial over Z5. So the initial polynomial, the fx, is basic irreducible. Now we move on to the main contribution part. So the main objectives are, the first one is to find the generators of the hull of a code, of a cyclic code over the ring, and then we derive some conditions for the cyclic code to be LCD, and also we find the formula for the p dimension of the hull, and we also calculate the number of cyclic codes for a fixed p dimension. So first we begin with the finding the generators of the hull. For finding that formula for the generator of the hull, we first get the formula for the generator of the code and also its dual. Now with the help of these two, we get the generator of the hull. So for a cyclic code J, its generator over the ZP cube is given in this form. As we have already seen that the cyclic code is nothing but is actually an ideal. So this is a ideal generated by this. These are the generators. So the cyclic code have generators in this form, and similarly, it's a dual code. The dual of a cyclic code over ZP cube will have generators in this form. If cyclic code is given by this J, and then its dual will be given in this form, where the star represents the reciprocal polynomial of the corresponding polynomials. Now, with the help of these two results, we finally obtain the generator of the hull of a cyclic code. So again, if the code is given in the form of ideal, its hull is given by this. These are the generators. So next, so what we have seen in this generator of the hull, that these polynomials, these q0, q1, q2, q3, these are nothing but the factors. You can see these are nothing but the factors of these x to the power l minus 1. So the length is L for this code. So hence these are the factors of x to the power L minus 1. So for this, you can see that the factorization of this particular polynomial x to the power L minus 1 becomes quite significant. So next we have this factorization of this polynomial over ZP cube into self-reciprocal and reciprocal pair basic irreducible polynomials. So Q are actually self-reciprocal polynomials, and P and P star form the reciprocal pair. Now, with respect to this factorization, we proceed to find the conditions for a cyclic code over this ring to be LCD. So these are the conditions where where these indices U1 KL, V1 KL, W1 KL, these indices satisfy these conditions, then we get an LCD code, which is cyclic over ZPQ. Next, here we have one example where we discuss how we can find the hull of a cyclic code over the ring. So in particular, we are choosing the length to be equal to 7, and we set P to equal to 2, so that our ring is actually Z8. So as we have seen that the factorization, we need the factorization of this polynomial x to the power L minus 1. So we factorize x to the 7 minus 1 over Z8 in this way. Here we see that x plus 7 is a reciprocal, self-reciprocal polynomial, whereas these two, the other two polynomials form a reciprocal pair. Now, using the formula for the generators, we get get this cyclic code J, and we get the hull of that cyclic code in this form. Next, we're interested to find the formula for the p dimension of the hull. So first we see what is the p dimension. P dimension here, it is written in the footnote that p dimension of a code J is actually defined as the logarithm of the cardinality of J to the base p. So in the case of hull J, so it will be cardinality of hull J to the base p. So this is the formula for the p dimension of the hull of a cyclic code over the ring. And now we use this formula to obtain to count the number of cyclic cores which have the same p dimension hull. This is the result, which gives the number of cyclic cores over the ring ZP cube, which has the same p dimension of the hull. Here you can see that TL, here we have considered the same expression as we have seen in the previous slide for the p dimension of the hull. So is the same formula. So hull dimension, we fix it to the prefixed integer L. So for a fixed p dimension of the hull,
Sorry to
to be
interrupt you, but you have just 2 minutes to conclude your presentation.
okay, thank you. So we fix the p dimension of the hull to be equal to capital L, and with respect to this p dimension of the hull, we compute the all the cyclic codes over the ring ZPQ. These are some of the references which we have used. Thank you for your kind attention.
Thank you so much for your presentation. Ma'am, do you have any questions?
Yeah, this is a theoretical. So I have one question. Do these theoretical results have any specific application?
Yes, ma'am. For the hull, we use it to construct the entanglement assisted quantum error correcting codes. And further, as we have already seen, the particular in case when the hull dimension is 0, hull to be equal to 0, it becomes LCT. And which are particular class of linear codes which have various applications in preventing against side channel attacks and fault injection attacks. And other than that, the various algorithms which are used to check whether two linear codes are equivalent or not, the complexity of those algorithms depend on the hull size. So it has been observed that when the hull size is small, the complexity is less. So it is quite significant to study the dimension of hull and its sizes. That is, so that's why it has been studied in recent years.
Yeah, thank you for your answer. Yeah, good question and good
Thank you, ma'am.
presentation.
Sir, do you have
That
any
looks to
questions?
be a good work. Yeah. Thank
Thank
you
you,
for
sir.
the presentation. What's your future scope of this work?
Yes, sir. We can also find the quantum course as I have mentioned, the entanglement assisted quantum course from the hull. First, we compute the hull, and using them, we can construct the entanglement assisted quantum error correcting
Good.
course.
Thank you. We can move on to the next presentation, please.
Thank you so much for your presentation. So we'll be moving on to the next presentation. Next, we have Shahariar to present the paper titled OSCC Diagnosis with Deep Learning, a multi-CNN approach with explainability. Are you there? Shahariar, are you there?
Hello, this is Alo. My teammate Sharia Sultan Nomit is sick, so I will present today.
Okay, you'll be presenting on his behalf?
Yeah,
Okay, sure. You may please begin with the presentation.
okay.
Please start.
Hello.
Yes,
Our
start.
topic name is OACC Diagnosis with Deep Learning, a multi-CNN approach with explainability. OACC is a major global health challenge, accounting for about 90% of oral cancers. It's particularly prevalent in South Asia due to risk factors like tobacco use and HPV infection. Early detection is critical. Patients diagnosed early have an 80% 5-year survival rate compared to just 30% for late diagnosis. However, traditional is subjective, time-consuming, and prone to errors. Our goal was to develop an automated, accurate, and interpretable deep learning system to classify OSCC and normal cells using CNN and explainable AI techniques. Let's look at the problem statement. Conventional OSCC diagnosis relies on pathologists examine biopsy tissues under a microscope, which is subjective and inconsistent. Shortages of experienced pathologists and increasing healthcare demands often lead to delayed diagnosis. We need a solution that's accurate, automated, and transparent to earn clinical stats. Our approach combines multiple CNN models to classify OSCC and normal cells, enhanced by explainable AI tools like line and silence maps to make the model's decision clear and trustworthy. Some previous research has shown deep learning's potential of OSCC diagnosis. For example, Reedy et al. Achieved 98.64% accuracy with VCC19, and some reached 99% with efficient net B3. Hybrid models hit 97% accuracy. However, many studies overlook explainability, and some models are computationally heavy for clinical use. Our work stands out by comparing 5 CNN architectures, optimizing MobileNet V2, and integrating explainable AI to make prediction interpretable. Where is our methodology? As shown is the workflow diagram. It started with a Kaggle dataset consistent 10,000 images, 5,000 WCC, and 5,000 normal. We pre-process the images by resizing them to 224 into 224 pixels, normalizing pixel values, and applying data augmentation like rotation and flipping to improve model generalization. We evaluated 4 CNN models: BreastNet 101, Inception V3, Exception, and MobileNet V2. Before tuning MobileNet V2 for optimal performance, finally we used explainable AI to interpret the results. The dataset was split into 80% training, 10% validation, and 10% testing to ensure unbiased evaluation. We choose 4 CNN architectures for their strengths in image classification. BreastNet 101 is deep with residual connections to avoid vanishing gradients. Inception V3 excels at multi-scale feature learning. Exception uses drift-wise separable convolutions for efficiency, and MobileNet V2 is lightweight yet accurate. MobileNet V2 performed best, so we tuned it further. We froze the first 75 layers to retain pre-trained ImageNet features, added a global average pooling layer, a 256 neuron dense layer with segment activations, and a dropout layer to prevent overfitting. We use the Adam optimizer with a low learning rate and callbacks like early stopping to optimize training. In that screen, we can see the tuned MobileNet V2 architecture. Here is the result sections. Our results were promising. As shown in this table, tuned MobileNet V2 achieved an outstanding 99% across accuracy, precision, recall, and F1 score, outperforming all other models. The untuned MobileNet V2 scored 94%, Exception 90%, BreastNet 101 89%, and Inception V3 87%. The confusion matrix for tuned MobileNet V2 shows only 4 false positives and 9 false negatives out of nearly 1,000 test samples, highlighting its reliability. These results demonstrate that our tuning significantly boosted performance, making tuned MobileNet V2 ideal for VCC classification. To dive deeper, we visualize the training process. We loss curves for tuned MobileNet V2 show a steady decrease in both training and validation loss. With no signs of overfitting, the accuracy curves converge to 91%, confirming the model's robustness. The confusion matrix further validates this with 477 positives and 5102 negatives, indicating excellent class separation. This visualization reinforces the model's reliability for real-world VCC detection. Whereas the explainable part, explainability is crucial for clinical adoption. We use 2 techniques, LIME and saliency maps. LIME highlights superpixels that drive the model's decisions for VCC images. It focused on irregular cell boundaries, while for normal cells, it emphasized smooth structures. Saliency maps show heat maps for impactful regions. Bright areas are indicates why small pixel changes affect predictions most. For VCC, these are abnormal cell shapes. For normal cells, they uniform areas. This visualization helps to understand and trust the model's decisions by linking them to medically relevant features. In summary, our tuned MobileNet V2 model achieved 99% accuracy in classifying VCC and normal cells, outperforming ResNet 101 Inception V3 exception and untuned MobileNet V2. By integrating line and saliency maps, we made the model's decision transparent, addressing the black box issues of deep learning. This work supports early VCC detection, reduced diagnostic subjectivity, and paves the way for AI-driven diagnostics. In future, we plan to integrate multimodal data or comparing different explainable AI in real-time clinical settings. That's all about my part. Thank you.
Thank you so much for your presentation. Ma'am, do you have any questions?
Yeah, I have. Which dataset do you use for your implementation? Use it only on Kaggle?
It's only from Kaggle,
Uh,
a public data set.
Yeah. Oh, okay, thank you.
So, do
Thank
you
you,
have any
ma'am.
questions?
Yeah, I'm good with the presentation. You can go ahead to the next presentation.
Thank you
Thank
so
you.
much for your presentation. So we'll be moving on to the next presentation. Next, we have Nelson to present the paper title Towards a University CSIRT Analysis of Best Practices and Proposal of a Hybrid Model for Educational Institutions. Are you there? Nelson, are you there? We are unable to hear you.
Is confirming is
Yeah,
visible.
we can hear you. Yeah, you can please start with your presentation.
Yeah. Towards an University CRT, the Pontificia Universidad Católica en Ecuador. Agenda, Introduction, Study Objectives, Theoretical Framework, Success Stories, Methodology, Process Model, and Conclusions. Introductions. Digital transformation in university has exposed critical vulnerability. In USA, large and formal, the software is priority framework, comprising his ability and response in incidents. The objective is property, hybrid, a model adapted and academic environment. The last is study los objectives, analyze international best practice in USA, diagnostic and current state and cybersecurity, design and hybrid the model, promote an academic security culture. The theoretical framework is specialist and provider in response and security incidents. The models it uses is centralized, decentralized, hybrid. In reference is the ISO and ENISIA. The NAS name is 800 and 61. Success stories is typical in Ecuador. The agency is UCLA, is Red Clar, APN, and UDLA. In regional corporation and shared protocols is priority, the sequence and the framework. In institute case is methodology, mixed approbator, quality and quantitative. The phase is analysis of international practice, diagnostic of use, model design, validation, and with experts. And diagnostic is have received phishing more 7.4. The several attack something is receive training, regulations, and with standards. The proposed model is hybrid model, Central University, is technology in university, and the cybersecurity is detection and response. The source and the timeline is planification, responsive. The resource is analytics, forensic. The conclusion is the phase and critical security risk. The is urgent implementation of the institutional USA and hybrid model provides detection, response, and digital culture and international standards with depend the use model and and study objectives and theoretical framework y the success stories. Thank you.
Thank you so much for your presentation. Ma'am and sir, do you have any questions?
So no, I don't have any question.
Okay,
Yes,
so
thank you.
Yeah, did you compare your system with the other existing system to establish the efficacy of your system? Hello, am I audible?
yeah, I guess he has left the meeting due to some
No
reason.
problem, no problem. We can go to the next presentation, please. How many presentations left for the day?
Just the last presentation is left.
Yeah, that would be nice
Yeah,
to know. Please, we can proceed to the next presentation.
Yeah, so we'll be moving on to the next presentation. Next, we have Ramiro Ramirez to present the paper titled Safe Journey, Enhancing Road Safety Education and Promoting Behavioral Change through a Mobile Application. Are you there?
Yes, hello.
Yeah,
I don't have permission, please.
yeah, you can have the permission and start with the presentation.
Thank you. Thank you. Hi, my name is Ramiro Ramirez. I'm going to explain you about safety journey, enabling road safely education for preventing behavior change through mobile application. This result paper attainment for mobile application is a demo tool for a road safety education and a means to collecting information and provide in real time and feedback behavior, driver behavior. Traditional methods such as road safety tutorials are not relevant today to use a mobile technology. Hence, an improvement in research paper. This mobile paper was developed with a sole purpose to raising pedestrian endpoints so that user can use road, bike, paths, and safety correctly. Sensors such as GPS and pedometer on mobile device are also used to collect information and processing it in real time and provide feedback for all users that walking in the road. Using clouds such as database, maps, authentication service, and technology with, for example, React Native make a mobile application accessible and usable. Texting, we have a very good result for getting data and processing. The application development followed agile methodology such as Scrum. Interactive approach provide every effective manage information projects approximately and adapting involving requirements. A sprint will create it through requirements rating and product backlog generation. This is the sprint we get it for developing this software. For example, sprint 1, improving user authentication with a far-based technology. Number 2, developing real-time feedback. We get all the GPS data and processing and sending to the cloud, etc., etc. The architecture we use in this project with data visualization layer where users such as pedestrian drivers and cyclists we review and transmit this data to generate in real time through mobile device sensors using React Native. The data captured, processed, and sent it to the Firebase cloud backend and processing and storage. React Native compiled the application native code in two platforms, for example, iOS and Android. The web application helped administrators to manage and data and general levels, and also collecting information such as pedestrian crossing, traffic signs, backlines, among others. Initially, we involved this project with making a construction prototype in Figma that app requirements. The prototype included access models, display map displayed, information and traffic laws and signs, and result on this behavior. The prototype helps options were developed in time. Finally, the mobile application built featuring navigation and navigation button bar, selecting the My option using respective icons. The My section displays the user's location on the map. Driver's education included a traffic laws, signs, and provide information and arrangement in user. First, the data it collect the GPS points and the road elements such as zebra crossing, traffic signs, road bike, line dimensions, and traffic lines. The purpose of this data is to provide a repository of the data and comparing to the road users and provide behavior feedback. For example, provided action included not walking, not bike lines, no parking in a private place, and other stopping signs. An evaluation section displays the result of the other behaviors in the roads. With helps with the data of the GPS, we can show them on the map. We can use it, extract the location and mode transportation using the real time, whether we buy a car, a bicycle, or a float. Once the zebra crossing and traffic signs and graphical display on the map. Using a GPS sensor, we promise generate by user, we can obtain the latitude and longitude coordinates in real time and send to the Firebase clouds and processing and reviewing any user mistakes or behavior on the clouds. This section we created to display the application, and we can manage this information via application mobile. This is the form we can manage this data, and we can display all the information on the mobile application. To deploy the application, we have to manage on the iOS and Android, and we can make this testing, forget all the data, and have a big repository. This is the example of the testing. For example, latency in real time, data storage, and rival device compatibility in many device, operation system, and cloud data connection. In fact, this is an innovation. This is an innovation research work because we can get a lot of data and know what is the behavior of the pedestrian and drivers and bikers. What is happening in the road? Accessibility and compatibility exchange. The app must improve and accessibility for the people with displays and expand support of iOS, adding adapting region to the regional reach. The future of this project, we can implement some gamification, make a simulation of what happens if I have a mistake crossing the roads. We can, if a crash, for example, I am parking in a stop signs, etc. Interactive simulation, map and traffic scenarios, practice and real-time simulation, and in edge learning. In conclusion, Safe Journey provides to be a promotion for tools for improving road safety, education, and promoting a behavioral change. Thank you very much. If any questions?
Thank you so much for your presentation, ma'am and sir. Do you have any questions?
Yeah, thank you for your presentation, and I think it is a very useful application. I have a small question about your architecture. For example, I saw that you have used the file-based to store the data. And do you think that file-based scalable enough to handle a million of concurrent users?
Yes, because this is a prototype, we have and we don't have a lot of post and get data. But if with the testing we have 100 petitions, the data is low. But if we have too many data to get and post, we have to pay and use all these service that have a file-based service.
Another question. In case of temporary disconnection, how does the application will handle the data storage and
Yes.
synchronization?
Yes. The application have a local storage when the connection is down. When the application is calling data in local storage, when the device detect a signal, start to sending all the data to the cloud, and this the information don't forget.
Yeah, good job. Thank you.
Thank you.
Yeah,
Sir, do you
Ramiro.
have any questions?
Yeah, very simple. I understand this is a prototype model, right? So what kind of technical challenges would be arised when you scale it to the real time?
The information to send the data is once per second to sending data. It have a lot of latency because sending a lot of data. The Firebase service, we have to receive all the information.
Yeah, good. Thank you. You need a lot of storage when you use cloud for the local storage in the real time.
Thank you. Thank you so much.
Thank you so much for your presentation. With this, I would sincerely like to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 6 to 7 months. So kindly cooperate with the team of ICTIS 2025. Before ending this session, I would also like to take a moment to thank our session chair, Professor Tran, for chairing this session. Thank you so much, ma'am. Would you like to share a quick closing remark with us?
Yeah, thank you so much, and I hope I'm very proud to have you to have this conference success. Thank you.
Thank you so much, ma'am. I would also like to take a moment to thank Professor James for chairing this session. Thank you so much, sir. This is a token of appreciation to the chair on the behalf of whole team and Global Knowledge Research Foundations and partners. Would you like to share a quick closing remark with us?
Yeah, thank you for the opportunity. I always thoroughly enjoy, especially the events that are organized by Amit and Chahar, the GR Foundation team. So it's a pleasure. Thank you.
Thank you so much, sir. Thank you everyone for your valuable presence. Before ending this session, I would like everyone to kindly turn on the cameras for a quick snapshot. Thank you so much, everyone, for your valuable presence. Thank you. Bye-bye.
Yeah, goodbye.
Thank you. See you. Thank you very much.